Hey, what's up everybody? Welcome back to another layer by layer tutorial. In this week's project, I put together this enclosure for a Raspberry Pi arcade. So this is using the Adafruit arcade bonnet and a couple of arcade buttons and an analog joystick. This design, however, is a little bit more reminiscent to sort of a laser cut design. So it's got these panels that all kind of snap together. So they're all printed in individual pieces, or they could be laser cut out of acrylic or whatever type of material that you can laser cut or CNC mill even. So the way that works is that there are the top and the bottom panels have these slots, and then the side panels have these little tabs that fit into those slots. So what if I can do here is make a marquee selection, hide them, then you can probably get a better look at the slots. So you can see these slots here. There's two on just about every side here. And then if I bring back these guys, maybe I can hide this over here. And then you can get a better look at the tabs. So you can see here the tabs are all kind of sticking out there. And they're about the same thickness of the material itself. So when I was coming up with this design, I needed to make sure that I had some tolerances so that the tabs would be able to fit into those slots. So if I look at it from the top, you can probably see a little bit of a gap here, a little bit of clearance. So I was doing that. I figured that I needed to use some user parameters to make it a little bit quicker instead of having to update every single little thing. And then I figured instead of making individual tabs for every single panel, I could just use some user parameters and some mirror commands so that this thing is more parametric. So I figured I'd do that and make a little bit of a template for you guys. So that's what I have here. So this is basically the same type of design, but it's all driven with user parameters and a couple of sketch-driven constraints. So let's take a look at the user parameters. Take a look. So the first thing we can play around with is height. So if I wanted to make our enclosure a little bit taller or shorter, I can do that. And the slots and the tabs all update as well. So that's really nice. So let me change that back. Another thing is, of course, the width and the length of this thing can change. So maybe I can drop this down to like 60 and maybe this down to like maybe 100 or 80 or something. And hopefully it doesn't break the design. That looks okay. Obviously, this isn't going to work for all of the sizes of enclosures, but it's got a pretty decent range here. So I think that'll work okay. Now, as I'm changing that, you might notice that the tabs in the slots are also changing as well. So those are driven with a little bit of math too. So we'll take a look at those in a second. Another thing to note is that with these type of laser cut designs, you kind of get these corners where the edges could intersect if we don't have a proper fillet. So let's take a look here. So I have a fillet here going across, and if I increase it something extreme, you can see that it is actually, the edges of these panels are actually constrained to the beginning of these fillets here, so where these edges are. So if we look at it straight on, from like the front view, you can see that it's straight on there, and that's because I have in the sketch, it's driven with a collinear constraint. So what's really good about that is that when you want to add corner standoffs, it kind of closes that off. So if we take a look at my arcade project over here, you can see that I have these standoffs that actually hold the whole structure together. So if I hide it, you can see that there is indeed a little gap there, and that kind of works out well, okay? So that's cool. Another thing is, of course, the tolerances for the slots, which is really like the main thing about this project. So you can see here that there is a little bit of clearance here. I have it called tab gap because it is the gap in the tabs. I could have called it a slot tab or whatever, but that's okay. So I'm going to make this a little bit more extreme, maybe make this 1 millimeter, which is huge. So depending on your manufacturing process, maybe you're laser cutting, maybe you don't need a tolerance so extreme. I know for my 3D printer, I needed to have a little bit over 0.4, 0.3 millimeter of clearance. So maybe this is 0.2. So it's really nice that you can be able to set 1 and all of them update. So let me look here. 1, you can see all of them extreme, not only the top, but the bottom as well. So they're all being driven with the same user parameters. Let me drop this back down to 3 or 4, whatever it was. Doesn't really matter because I'm not manufacturing this right now. But hey, those are the main things that you can change in this. And of course, the length and the height and the width of the enclosure is really nice. So let's take a look now at how I kind of developed this template. So if we step all the way back, we can kind of get a look at what we started off with. So really, it all is driven with just one sketch. Well, most of it is. So the bottom is one full sketch. Let's go inside of it and take a look at some of the things. So it's just a 2-point rectangle with some parameters. So basically I have a width for this edge here. It's a constraint, or not a constraint, it's a sketch dimension. And at the bottom here I also have another sketch dimension, but this one is length. So inside of our user parameter window, you basically just add a new thing, call it length, and then add your value here, which is the length. So that is subject to change, so it doesn't really matter what it is, but we can test it here by just go ahead and going in here and updating it. So you can see that 80 turned into 100, and maybe this one changes to 50. So you can see how it quickly updates that right there. So that's how that's being made. Once I create the sketch, we step forward. Let me hit stop sketch. We basically extrude it out. And instead of adding like an actual fixed number like 1 or 3, we actually create yet another user parameter and call it thickness. So this is actually the thickness of our material. So if I bring back our user parameters, you can see that the thickness is set to 2. A lot of the times acrylic is about 1/8 of an inch. So you can do a little bit of math and conversion it and say I want it millimeters. So let's say I want 3.7 millimeters. I can just drop that in there, hit OK, and automatically update. So this is really powerful, I think, especially if you're CNC milling and you want to create some CAM toolpaths. You want to make sure you have your stock is the correct thickness. So with that done, the next thing I ran through is the fillet. So I did want this design to be a little bit more smoothed out, so I added that fillet. And of course, instead of adding a value like a number, I added a user parameter. So I called it fillet. Perfect. So the next thing I did is I created the top. And in order to do that, you could reuse the sketch and then tell it to be an offset. But instead what I did was I used a plane. So this guy over here is a plane. You can create construction planes from the construction window over here in your model workspace. It's basically called an offset plane. So what you do is you click on that button, you click on a surface, and then you pull it up. Now, instead of adding a fixed number for the distance, I actually typed in height. Height is going to be a user parameter. So if we take a look at our user parameter window again, you can see that height is there. It's at the 30. So with this plane created, now I can draw a sketch right on top of it. So I have it selected here, and then I create the sketch button, and then we can start creating our sketch for our top plane, or really our top panel. Really all I did for this one was I actually projected the sketch. So I clicked on this surface here, and then I hit the P keyboard. You can go to sketch and dig down to the menu and click on project, and that basically created this little sketch here. So this sketch will update whenever I change any of the width or the length. So let's do that real quick so you can see that since it is a projected sketch, you can tell it's a projected sketch because the outer line is actually purple, and that lets us know that it is referencing something. So as I select it, you can see here it's kind of making this kind of change a little bit of color, so it lets me know that that is being projected from there. So let me change that back to 80, and you can see it change again. So that's how that's being done. There's really nothing else in here. That's all there is. So with that sketch created, I can then extrude it out again. Instead of adding a real value, I actually add the thickness user parameter, so that'll always update. So now I have these two. I have my top and my bottom, and what I can do is I can play around with it and make sure that it's working. So if I wanted to change the height, I can make that taller. If I wanted to make this a little bit wider, I can do that. Make the length a little bit shorter, I can do that as well. So that's working out really well, and I'll hit OK. The next thing I wanted to do was create, I believe, the front. So the front panels is what I worked with. So again, I did another plane. So this plane is actually driven from this edge here from the bottom. So I click on that edge. With it selected, I click on the offset plane. So when I click on that button, you can see what it's doing here. So instead of adding a distance, again, I add, I do thickness multiplied by 2. So if I only had thickness, it would be right off of this plane. And when you're doing laser cut and you're doing those tabs and you want those slots, you probably want to increase the distance away from the outer edge. So I do that with a little bit of math here, just saying that get the thickness and multiply it by 2. So that's how I created that plane, and I called it front plane so that I know it's from the front. Using that plane, I can create my next sketch, and this is where things get a little bit interesting. So in this sketch here, this one is what's driving the front plane. So let's go ahead and jump inside of it and see what's going on. In here, if I hide my bodies, you can probably get a better look of it. Basically, I started off with a 2-point rectangle, and then I added some construction lines, these little dotted lines that are running across the middle. you know they're in the exact middle because there is a midpoint constraint. So that's how I'm able to create really quick mirrors that are symmetrical. So I basically create these vertical and horizontal lines, create them into construction lines, and then I can use those as little tools for mirroring. So once I have that, what I need to do is actually make some collinear constraints for these edges here, the left and the right edges. So what I did was I brought out my bottom here. Let's see if this is the bottom. So I brought out my bottom and I basically took the edge right here. I clicked on that edge and then I hit the letter P on my keyboard to project that in. So with that projected into this sketch, I'm actually using that as a reference point. So I can basically say I want that edge to be lined up with this projected edge. And to do that, I use this collinear constraint. So I basically do that for that side and for this side as well. I also did it to the top and the bottom edges here. So if we look at it from here, you can see that there is a little bit of gap in between here and here. Now for 3D printing, the material tends to expand when you're extruding, so that's why I have a little bit of distance. If you were laser cutting, I believe you would probably have it right up against that edge there. You could use a collinear right there, but for me, I used a what do you call it, a sketch dimension, and I have my little gap here, which is another sort of tolerance thing that's a user parameter. So I have that up there, so there's a little bit of a gap there, and a little bit of a gap down here, so those are consistent. All right, so once that sort of main panel area was done, I had to figure out how to do the tabs. So let me go ahead and hide these bodies again. So you can see the tabs here. I basically created one 2-point rectangle. I just kind of threw it there, and when it was floating up here, I basically attached it to this using another collinear constraint. So this will always be the bottom there. The next thing I did was I added yet another construction plane to the center of this tab. Also, the tab has a width that is dynamic. So inside that, I have something called tab width. So tab width is basically something that we can modify if we ever need to. You could also drive it with the length. So I can say the length of the entire enclosure divided by 4, for example, and that will give me 30. So that's probably a better way to do it, so that this tab will grow with my enclosure. The height of the tab is actually the thickness, because we want the tab to be the exact same thickness. So that's why I have the thickness there. We could also add the tab gap, or just the gap here, so that it is right up against that, so you have a little bit of extra rooms here. So you can use a little bit of math to make this work a little bit better. Now to get the distance of the tab, I basically set a sketch dimension using a little bit of math again. So I say multiply or divide the length by 4.5, and that gives me this distance here. It's almost perfect, so we can test it out now. But once I had that distance set to the mid-construction point, the midpoint construction line, then I could basically take this tab and then duplicate it using a mirror command. So here we can use mirror. We have a mirror over here. It's exactly symmetrical, so whenever this changes, all of these will change as well. So once this first mirror was done, I selected the 2 and then mirrored it on this line, and that's how I get my 4 tabs. So these 4 tabs are mirrors of just this one tab. So that's how that is working. So if I come into my parameters window, I can go ahead and modify this. Let's go ahead and change the length, and now you can see that my tab length has been changed because it is being driven with a little bit of math. So it's basically the length divided by 4, and then the distance of the middle of the tab is at a distance away from the middle of the panel. So that's this guy here, this dimension. So it's basically length divided by 4.5. If I got rid of the 0.5, you can see that they're a little bit more off away. There's a little bit more distance in between the 2 tabs. So that's why I put a 4.5, just to kind of bring them closer together. So that's how that's working. And of course, as I change it, all these mirrors are working in conjunction with it. So I'll hit OK, And when that's created, I basically extrude it out, and instead of adding, again, a fixed number, I add the thickness parameter, so that will always update. So let's go ahead and hide our sketches and then bring back our planes. So you can see here that there is that little bit of offset. So if I wanted to get rid of that offset here, instead of adding a thickness, let me get rid of the multiplied by 2, and now you can see that it is right up against that material. I guess if you wanted to have it this way, you could totally do so, but it's really easy to come in here and just kind of add that little divided by or multiplied by 2. Now I have that distance there. So we're getting there. We almost have most of our enclosure done. So the next thing I needed to do was to mirror this front plane so that it's exactly on this side as a duplicate. So to do that, I need to figure out what is the middle of this edge and that edge. And to do that, we can do that with one simple construction. It's called a mid-plane construction. So it basically allows you to create a mid-plane in the intersection of two faces. So to do that, I just click on this edge and that edge, and then click on the mid-plane button. When that happens, I'll automatically get this guy here, which is my mid-plane on the x-axis. So now I can do a mirror and just mirror this body on that mid-plane. So that's how I get this. So this is an exact copy of this first one. So whenever I update any of the user parameters, it'll just follow that. So let's go ahead and do that. 120, for example, you can see that it is growing, the tabs are growing, and that's pretty awesome. Even more so. There we go. Looks really good. So the next thing I need to do is create our side panels. This is the front and this is the back, whatever you want to call them. Now we need to do the left and the right. So to do that, I create kind of like we did with the front. I selected this guy, created an offset plane, which is this guy over here. And I followed the same thing. I said thickness multiplied by 2. So I get that plane, and then I can create my sketch. So let's go take a look at this sketch here. This sketch is very reminiscent to the front plane. So if I hide all my bodies, we can get a better look at it. It is a little bit smaller. So what I did was for this one, the tab width is divided by 2, which actually should be the length. So you can see it's really, really big. So depending on if you have a perfect rectangle or a perfect square, you might want to update this. So I might put divided by 5, for example, here. That way it's a little bit longer. And then we can set the distance is actually divided by 8.5. So this should probably be 5.5 or so. No, I think 5 was fine. So that looks good. And of course we basically did the same stuff. So we made sure that the edges here are collinear with the edges of the bottom here, and that's working well. We also have our little tolerance gap from here to here. So this is basically exactly how the front end with a little bit of math adjustment here. So instead of like 4.5, we're doing 5 here on the tab length, and of course the distance of the tab, the center of the tab away from the distance of the center of the panel. So that's how that's working. And then once that sketch is done, we can extrude it out using, again, our thickness parameter. And then we do what we did with the first one, with the first front and back panels. We make another mid-plane, this time going on this edge and that edge. We get the middle mid-plane here, and then we can use that as a little reference point to create our mirror. So now that we have all 6 panels, we need to create our cut. So what I did was I clicked on this top, or actually I clicked on the bottom panel. With it selected, I created a sketch so that it projects it automatically. And once I did that, I then brought in a couple of projected sketches. So what I did was I hid the top and the bottom, and then I projected in one of the fingers on this front panel and one of the fingers on the side panel. Now, because everything is symmetrical, I can do kind of the same deal with these construction lines that have a midpoint constraint to the outer edges going on horizontal and vertically. And then I can use those to duplicate these guys. Now, to create my little gap here, I basically projected those tabs in, and then I created an offset. So to do an offset, you can click on O, I believe it's up here under Sketch. Offset is right there. and then you can use that to create an offset of these projected sketches. So I'm going to kind of show you a visual example of how this works. So instead of adding a number, you basically type in the gap here. So tab gap, and that's how I was able to get those. So once I created my one over here and one over here, I could double click on these chain selections and then mirror it on this line horizontally. Once that was created, then I mirrored this on the horizontal line. That's how I was able to get the symmetrical 4 times across here. So once that's done, I created an extrusion right here. Let me bring back my bodies. So if we double click on it, you can see what it's doing. So it is actually cutting, and the extent, instead of adding a distance that's kind of like a fixed number, I basically say to object, I want it to cut from the top to this object and cut all the way through. Now, when you open the objects to cut, you want to make sure that the top and the bottom bodies are selected and not the sides. So make sure those are not selected. The chain faces seem to work okay with chain faces. So that works okay, and it is of course a cut. So when I hit OK, it cuts through just the top and the bottom. We got a little bit of an intersection here. Looks like I need to update the fillet. Maybe the fillet needs to be a little bit bigger. So let's go ahead and do that. I'll make this 10, and there we go. That opened it up quite a bit. And you can just keep playing around with the numbers until you get something that you like. But that is pretty much, in a nutshell, how I created this little template here. It might work for you, it might not. If you are somebody who creates laser cut designs and you find it useful, or you think it's not really necessary, or maybe I'm missing something, I want to hear from you. So let me know what you guys think about that, since I don't really do much laser cut stuff. But I figured I'd try to 3D print this out as you saw in this project here. And if you want to know more about this project, I do have a full tutorial on it. You can go to learn.adafruit.com, and also the link in the description of this video. You'll be able to see all the links that I have, even the Fusion 360 files for this template, and of course this design here, which is a little bit messy, but I apologize for that. But anyway, that's what I wanted to share with you guys. I think it's kind of a neat thing. So let me know what you guys think, and I'll see you guys in the next one.